Hello, fellow math enthusiasts. Get ready to embark on an exciting journey into the world of numbers. Today, we'll be exploring 4 fundamental concepts that form the bedrock of mathematical understanding. Whether you're a student looking to ace your next exam or an adult wanting to brush up on your math skills, this comprehensive guide has something for everyone. We'll break down complex concepts into bite-sized pieces, making them easy to grasp and remember. So, grab your thinking caps and let's dive right in. Get ready to unlock the secrets of Bidmas, long division, long multiplication, and prime numbers. Section 2. Cracking the Code. Understanding Bidmas. In the realm of mathematics, order is everything. Imagine trying to bake a cake without following a recipe. Chaos would ensue. Similarly, when solving mathematical expressions, we need a set of rules to ensure consistency and accuracy. This is where Bidmas comes in. Bidmas stands for brackets, indices, division and multiplication, from left to right. Addition and subtraction, from left to right. This acronym serves as a roadmap, guiding us on the order in which we should perform mathematical operations. Let's illustrate with an example. 5 plus 2 times 3. Without Bidmas, we might be tempted to add 5 and 2 first, then multiply by 3, giving us 21. However, Bidmas dictates that multiplication takes precedence over addition. Therefore, we first multiply 2 by 3, resulting in 6, and then add 5, giving us the correct answer of 11. See how Bidmas helps us avoid ambiguity and arrive at the right solution. Remember, practice makes perfect. So grab a worksheet and start solving. The more you practice, the more confident you'll become in applying Bidmas to any mathematical expression. Section 3. Long division. Demystified. A step-by-step guide. Long division, often considered a mathematical monster, is actually a gentle giant once you understand its ways. It's a systematic process of breaking down a division problem into smaller, manageable steps. Let's tame this beast with an example. 782 divided by 6. First, write the dividend. 782 forming 18. Step 5. Repeat the process. How many times does 6 go into 18? It goes in thrice. 3 times 6 equals 18. Step 6. Write the 3 above the 8 in the quotient. Step 7. Subtract 18 from 18, leaving 0. Step 8. Bring down the last digit, 2, to the right of the 0, forming 02. Step 9. How many times does 6 go into 2? It doesn't go in fully, so we write a 0 above the 2 in the quotient. Step 10. Since we have a remainder of 2, we write it as R2. Therefore, 782 divided by 6 equals 130 R2. See, the monster is tamed. Remember, the key is to break down the problem into smaller steps and practice regularly. Section 4. Mastering long multiplication. Simple and easy. Long multiplication, like its division counterpart, can seem daunting at first glance. But fear not. It's all about multiplying in an organized way. Let's conquer this with an example. 235 times 42. Step 1. Write the numbers vertically, one above the other. Step 2. Multiply the ones digit of the bottom number, which is 2, by the top number, 235. 2 times 5 equals 10. Write down the 0 and carry over the 1. 2 times 3 equals 6, plus 1 from the carryover equals 7. Write down the 7. 2 times 2 equals 4. Write down the 4. You should now have 470. Step 3. Now, multiply the tens digit of the bottom number, which is 4, by the top number, 235. 4 times 5 equals 20. Write down the 0 below the 7 in 470 and carry over the 2. 4 times 3 equals 12. Plus 2 from the carryover equals 14. Write down the 4 next to the 0 and carry over the 1. 4 times 2 equals 8. Plus 1 from the carryover equals 9. Write down the 9 next to the 4. You should now have 9,400 below the 470. Step 4. Draw a line beneath the 9,400. Step 5. Add the two products. 470 plus 9,400 equals 9,870. Therefore, 235 times 42 equals 9,870. With practice, you'll be multiplying large numbers with ease. Section 5. Prime numbers unveiled. The building blocks of numbers. Prime numbers hold a special place in the world of mathematics. They are the building blocks from which all other whole numbers are formed. A prime number is a whole number greater than 1 that has exactly 2 divisors, 1 and itself. Let's look at some examples. 2 is a prime number because it can only be divided evenly by 1 and 2. 7 is a prime number because its only divisors are 1 and 7. 11 is a prime number because it's only divisible by 1 and 11. On the other hand, numbers like 4, 6, and 9 are not prime numbers because they have more than 2 factors. 4 is divisible by 1, 2, and 4. 6 is divisible by 1, 2, 3, and 6. 9 is divisible by 1, 3, and 9. Prime numbers play a crucial role in various mathematical concepts, including cryptography and coding theory. Identifying prime numbers is like a treasure hunt, challenging yet rewarding. Thank you for joining me on this mathematical adventure. Remember, the key to mastering math is practice, practice, practice. Stay tuned for more exciting mathematical explorations in our next session.